I wanted to do one problem right out of Alex, especially because sometimes it pops up with the p-value, and I didn't really go over that in my versions of the notes. So I thought it'd be a good idea to work one of these problems. That way you'll have an idea of what you're supposed to do when you're working the homework. So here we have a wedding magazine, Matrimony Monthly, and they're saying that in their research, popular conception has been that 50% of first weddings take place indoors, 30% indoors in a building. So 50% indoors in a church, 30% indoors in a building, and 20% outside. And they're telling us that we have a total of 260 first wedding. That's pretty much all the information you need from here. So if we jump down to our contingency table, they have observed values filled in for us. Out of 260 weddings, 154 were in a church, 66, I think that is, were in a church but were inside but not a church, and 40 were outside. So to get the expected frequency, I go back to those percentages. So we were told that 50% were in a church. What was the other one? 30% inside but not a church, like at a hotel or something real quaint like that, and 20% outside, like on the beach or at a park. Okay, so I know a total, and to get the expected values, I'm going to take those percentages and multiply by the total. So the expected value here would be 130 in a church. 30% times 260 would give me 78 inside but not a church. And just to double check, 20% times 260, that's where that 52 comes from. Down here, this is where you're doing your O minus E divided by E, and their notation is a little bit different, but the formula you're probably used to seeing is O minus E quantity squared divided by E, and it's the same thing. They just wrote it a little bit differently. So here for church, I'm going to take 154 minus 130, that quantity squared, divided by 130. And that gives me 4.43. I think they want you to round those to 3 decimal places, so I better put 4.31 because I have an 07 in my calculator. For indoors but not in a church, I would do 66 minus 78, that quantity squared, divided by 78, and that gives 1.846. And for me, I'm just a stickler. I'm going to go ahead and double check that last answer, even though I know it should be right since Alex put it there. But 40 minus 52, that's quantity squared divided by 52, does indeed give us 2.769. So those are my the difference between the observed and the expected divided by the expected. Now, here on this drop-down menu, this is not a live screenshot, but here they're going to ask you whether you're doing chi-squared or f or t. So obviously we're going to do chi-squared. And when you pick that, the degrees of freedom are going to pop up. And the degrees of freedom will be the number of categories minus 1. We have 3 categories, so the degrees of freedom here would be 2. Now for our test value, or the value of the test statistic rather, we're going to add up these last 3 numbers. So that 4.431 plus 1.846 plus the 2.769, and that gives us 9.046. Now the p-value, what that's asking for is what is the area in the tail past the test statistic. And there's 2 ways you could do that. You could do it with your chart, or you could do it with your calculator. On your calculator, just like with binomial and normal, you have all those distributions. If you press second distribution and go down, for me it's number 8, you want to choose chi-squared CDF for cumulative distribution function. And it's very similar to the argument you used to put in for standard normal. You want the left bound, the right bound, comma, degrees of freedom. So in your calculator for p-value, you go into your distribution menu, and you go to, it should say chi-squared CDF. It should look like that. And then in your main screen, you'll get chi-squared CDF pop up and a parenthesis. You have to know the argument. So the lower bound for us would be 9.046, because if you remember your picture, remember we're going into the tail. So what I'm saying is I know that this is 9.046. I want to know what this area is in the tail. That's what the p-value is. So the left bound is 9.046. I'm going pretty much to infinity, so like I usually put in something like 99999. And then the degrees of freedom are 2. And when I do that, I get, for my calculator, 0.01085 da 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 da. Okay, and then let's see. You could also do that with the ALEKS calculator. Let me see if it'll pull up. So you have, here's your chi-squared here, and we want to be greater than our test value, 9.046. And notice they have a box for you there, degrees of freedom 2. And you get the exact same thing, that 0.010856. So that's what they're asking for with a p-value. This one is not so reliable as getting it from the table. I think the table wouldn't give you a good level of accuracy here. So I would either use a calculator in ALEKS or use your TI-8384 to get that value. So here for p-value, since they want us to round to 3 decimal places, I would say 0.011. And you're not going to get that from your table, so you'll have to use some technology to get that one. Then finally, they ask us, can we conclude that the actual distribution of locations of first wedding is different from the distribution in the magazine's popular conception? So our hypothesis is, the null hypothesis is, yeah, they're the same. The weddings are distributed as the magazine said, about 50% in churches, 30% inside but not in a church, and 20% outdoors. With the p-value, if the p-value is low, the null has to go, is pretty much the sentiment I have in my head. So this is a pretty low value, and it's lower than the 0.1. So we reject that null hypothesis, and we're saying that yeah, they are different. Another way we can look at that is if you, now it didn't ask for it, but they're telling us to use 0.1 as a level of significance. We could look that value up on our chi-square chart. So if we kind of go back to what we're used to doing, so 2 degrees of freedom and go over to 0.1, and that gives me 4.605. Well, from before, our test value is over here at 9.046. So I'd get the same conclusion to reject H naught, which means weddings are not distributed as the magazine thought. They're different, and that's what they're asking. Are they different from what the distribution of the magazine popular conception says? Yes. So that's what's happening with the p-value. You have to get that test statistic first, and the p-value is saying what's the area in the tail from this test statistic value. And if the p-value is lower than alpha, then you reject the null. But if you feel more comfortable, you can go back to the traditional way of doing it and compare the test statistic to the critical value by using alpha, but you'll get the same results.